Hi everyone. Hi Abubakar. How are you?
Sam, I'm doing well. I'm doing well. How about yourself?
Good. Alhamdulillah. Okay, so we'll be starting. Welcome everyone to another PyData Riyadh webinar, where we are honored to be joined by Abubakar Abid to talk about building a visual interface for machine learning models with Gradio. I'm Dania Dosari, and I'll be moderating the talk today. Working alongside me as part of PyData Riyadh, Abdullah Al-Numay, ربى المروتي, Abdullah Al-Misfir, Sara Salman, and Najla Al-Baz. Before handing it over to Abubakar, I just wanted to formally introduce you and mention some of your amazing achievements for everyone. Um, Abubakar is a PhD student at Stanford with an undergraduate and graduate degree from MIT. For over a year now, Abubakar launched his new company, Gradio, where he aims to make machine learning models more reliable and effective in academic and business settings. The session will last for 50 minutes, with the last 10 minutes dedicated for Q&A. But do not hesitate to drop a question in the Q&A section, as Abu Bakr will be happy to answer any questions during the session. So without further ado, Abu Bakr, the stage is yours. I'll be making you the host now.
All right. Let me see if I can go ahead and share my screen. Can you allow me to share my screen here? Okay, I can do it now. Wonderful. Thank you so much for the introduction, Dania. It's really my pleasure to be here with all of you today. I know it's pretty late over there in Riyadh right now, so thank you so much, everyone, for coming out. And thank you so much for the kind introduction, Dania. So as Dania mentioned, I'm going to be talking about building better machine learning models using this thing that we built called Gradio. So this work came out of my research at Stanford, as well as now it's spun out to be a company, Gradio, as well. And as Dania mentioned, I would love for this to be an interactive session. So I'm going to try to make it interactive on my end, but feel free to come in and ask any sort of questions throughout. You don't have to wait till the end. Okay. All right, let's jump into it. So what I'll be talking about three things. First, I'll be talking about why we actually built Gradio. What is the problem that we're trying to solve? The second, I'll show you concretely how Gradio works by walking through a notebook, a Python notebook, where we actually use Gradio in practice with a few simple machine learning models. And then finally, I'll show a real world case study that we did with Gradio at Stanford in an application of machine learning to cardiology. All right, let's jump into it. So one thing I will mention is that your feedback is really valuable. And if there's any sort of ideas or additional features that would be helpful for your work, let me know. This is still an active library in development. And so I really want to hear any sort of new features or new additions that you have in mind that would be useful for your work. Okay, all right. So I'm going to start off by making a claim that I think is pretty, if you're following recent trends in machine learning, you've probably heard this. Machine learning has a trustworthiness problem, okay? And let me just share a few articles that I've, seen over the span of just 1 month, actually. This is an article that came out in the MIT Technology Review. This is how AI bias happens and why it's so hard to fix. This is another article also in the MIT Technology Review talking about how machine learning is contributing to a reproducibility crisis. Here's another one talking about the explainability problem in machine learning. And finally, another one talking about the reliability or lack of reliability that machine learning methods often have when they're applied to the real world. Okay, so as you see these articles, or as I see these articles, a question that I am thinking is the media overhyping this problem, right? I think we've all seen examples of, the media creating an issue where maybe there isn't an issue. Is this an example of that? I actually don't think so. I think if anything, the issues of bias and these other issues that I've brought up are actually underexplored. Here's an example that actually came out of our lab. We were looking at a state-of-the-art image classifiers trained on ImageNet. This is, these are, as I mentioned, state-of-the-art image classifiers used by many companies behind the scenes. Facebook, Google are using these kinds of image classifiers to make all sorts of decisions. And what these image classifiers do is they take an image and then they predict a single class or multiple classes that the image can fall into. So in this case, the image on the left is of a bride taken in the West, and the image classification system prints out things like bride, dress, woman, things that you actually wanted to predict most probably. On the other hand, on the right, you have an image of a bride taken in Pakistan or India, where I'm from, and you can see that the image classifier prints out things like performance or costume, things that are incorrect and could even be borderline offensive as well. Here's another example that kind of shows this. And many of you guys may be familiar with GPT-3, the machine learning system that was released by OpenAI that does text completion. You give it some text, and then it completes the rest of the sentence or paragraph. And here is how GPT responds with a few different prompts. When you prompt it with two Muslims, this phrase, you can see that it predicts very violent texts. If you continue priming it with other things, two Muslims walked into, again, it continues priming it with very violent text. You could try feeding in whatever you want to try to make it seem, to change the output of the model, but it's very hard to actually prime it away from producing this very violent type text. Now, even if you type in two Muslims walked into a mosque to worship peacefully, again, the text that it's producing is not what most people would probably want out of the system. So the question happens, why, machine learning has all of these issues that we've identified, these untrustworthiness issues. A, that it's hard to reproduce. B, that it has bias, the models have bias. C, that the predictions are oftentimes unexplainable, or D, that they're unreliable in the wild. But I guess, so then that naturally leads to the question of why is that the case? Why do these problems actually happen? And let me maybe, pause for a second and just ask if anyone has any ideas here. Why do these issues happen?
I think you're on mute. I'm not sure if this is by accident.
Thanks. Yeah, that was by accident. But yeah, so a couple of people rightly pointed out that it's issues of data, right? So that if the data is biased, then we expect the model's predictions to be biased as well. But that itself leads to another question, which is why are data sets biased in the first place? Like, why did it take so long for people to realize that ImageNet has these, the ImageNet has these biased data problems? Okay, somebody else put in something. Because we are biased. Okay, sure. But then on the other hand, on so collection techniques, people brought up different things. Yeah, so on the other hand, yes, it's true that we as individuals were all biased, but at the same time, we as individuals also found these sources of bias as well. So it seems to be not, I think while it's accurate to say that it's just biased data, it's worth thinking about why did it take so long to figure out these issues of bias? How can we solve the human problem that results in these biased data sets? And so part of what I'm going to be talking about is actually is going to be addressing these problems as well. Okay, so and I'll give one more answer as well, which is separate but related to the issue of data, which is that I think it's actually a culture problem. The culture in machine learning is that we optimize all of our algorithms are optimized for let's get the highest accuracy that we can on the test data set. Okay, we have some test data set, like, okay, how high can we push this number? It's not really optimized for usability in the real world. And there is a distinction here for sure. I'm not saying it's necessarily an easy problem to optimize for usability in the real world, but I'm saying that is not what we optimize for, and as a result, we have all of these issues. Any questions here or any thoughts? Yeah, so to rephrase, what I'm saying is that if you think about it, for example, you take an issue like bias or even lack of reproducibility, we don't bother making models very usable because, or reusable or reproducible, because once we have this test accuracy on this test data set, we can publish the model, or we can release it, or we can win that Kaggle, competition. There's not really much effort made to actually make it easy to reproduce. Okay, it looks like there was a question. Oh yeah, and the reason for that stems from the urge to publish. Yeah, I mean, definitely, that's definitely part of it. You can get away with publishing something, even if it, I remember talking to one of my collaborators at Stanford. She had published this great model to predict patient motion in the ICU, and it was great. She published it, all this stuff. And I remember asking her, cool, we should try this out. Like, let's see if this actually works. Let's deploy it. And she was like, oh, I would never, ever trust this in any real ICU. And that's because, the incentives to publish don't really involve usability in the real world. And so I think that there's an element of that. Okay, so there's a question about why does that happen, and is it a generalization issue? It is absolutely a generalization issue. The problem is that our test data sets don't have to really be they're not really dynamic. They're kind of static. They're fixed. They don't have to be too representative of the real world. Like if you were to point out, okay, I think the test data set doesn't have these real world artifacts, that is much harder to publish than just a paper on, hey, this is a state of the art, better model on this test data sets. So there are less incentives to align the test data sets with generalization into the real world. Yeah. Another factor in that, and that's what I'm going to be talking about later, is in a lot of settings, like what ends up happening is that the machine learning developer is working in isolation. They're not really, as they're building the model, they're not really going out and giving it to a domain expert or to an end user to test their model. Okay, so they have this test data set. They're just focused on maximizing the accuracy. And that's something we feel we should change. And that's something I'm hoping Gradio can help contribute to changing. Okay, yeah. All right, if there are more questions, you can ask, but let me go ahead and move forward now. So how does Gradio help with this? And I'll be honest here. I don't think Gradio can solve the complete problem, but I do think that there are concrete contributions that Gradio can help with. And specifically, so what Gradio does is, if I was to summarize in one sentence, basically Gradio lets you create web-based GUIs from your machine learning models very easily, so that anyone, whether they have technical ability or not, can use and test your models. Okay. So this makes it really easy to test the model in diverse settings, flag problematic predictions, and collect rare data to add to your data set. Okay. Rather than me speaking theoretically, what I want to do is actually want to go ahead and show you guys the Gradio library. Python, you can follow along with me. In fact, what I would like to actually share this link to a Colab notebook, where you guys can actually run the Python code and actually make changes and play around with the Gradio library yourself, so you guys can actually give concrete feedback. Someone asked, is it open source? Yes, all of this is completely open source. So let me go ahead and actually share this link in the chat group. Once you click on it, it's going to open up the Colab notebook. And if you guys haven't used Colab notebooks before, they're basically just like hosted Jupyter notebooks. And if you want to run a particular cell of code, you can just run cells of code at a time. So if you want to run a cell of code, you just click on that cell of code and you press Control Enter. Okay. So let me go ahead and do that now. Oops. All right. I just went ahead and sent this. So you guys should be able to now click on the link and you should see something like this now. Okay. Okay. So yeah, so I'm going to go ahead and show it on my screen, but the way I recommend you use this is maybe minimize myself, and I'll just walk through the different cells of code. And then as I describe them, you guys can run them and edit them and do whatever you want. Okay, so this first part here, what is Gradio? I've already covered that. In terms of what problem Gradio is solving, I've talked about the bias-related issues. Here's just another very interesting example. There's a lot of effort now in like face reconstruction algorithms. You put in like a pixelated image and it produces a higher resolution version. The problem is that most of these algorithms, or most of these data are actually Caucasian faces. And if you put in, so for example, if you put in this picture of Barack Obama, he actually gets reconstructed as this white guy, basically, which is just very random. But in general, these algorithms work better on white faces and black faces. And that's the source of bias that, again, wasn't discovered because the model wasn't tested earlier on in real world settings. It was tested on this small test data set. Okay, let's go down to how do we actually use Gradio. So I'm gonna start off with section 0, installation. So Gradio is a Python package, and so you can just pip install it. So again, if you want to actually run this cell, just going to click on the cell and do Control Enter. And if you try running it the first time, you might have this message saying this notebook was not authored by Google. That's fine. It was authored by a company. That's completely normal. So you can just go ahead and click that. And you'll see that it's just going to go ahead and install Gradio onto the Jupyter environment. Okay, well, I'm just going to refresh this page because for me, this Jupyter notebook is a little slow right now. Connecting, okay. Are you guys able to pip install this? Let's see. Yes, okay, cool. Okay. Give me 1 second on my end. Okay. Well, it's showing up busy for some reason on my end, and oh, maybe I should terminate this and then restart. Yeah. Okay, connected. Cool. All right, so let me go ahead and run this now. So yeah, if you run it, you should see that it's just installing Gradio. That's completely normal. Now let's actually jump into an example. So Gradio at its core basically combines 3 ingredients. You have one, a Python function. The second thing you have is what is the input UI component that you want? And the third thing is what is the output UI component that you want? Okay, so let's again see a very concrete example of this. So here I have this function called replace. Okay, and all it does, it takes a string and it replaces the word world with the word Riyadh. Then I create a Gradio interface object that takes in a function, it takes in an input, and it takes in an output. Okay, and then you just do .launch, and then share equals true. I'll explain what this is in just a second. And I go ahead and I run this code. Okay, so I'm going to go ahead and run this code right now. And what this is going to do is, if everything runs smoothly, this should go ahead and create. Might take a little bit of second. It might take a second if a lot of people are using this. It's fine. I'm just going to go ahead and open this link. So what's happening here, let me just explain while this code is loading, is that I'm basically telling it that the appropriate inter-UI component for the input is a text box, and the output is also a text box. So let's give it a second. Okay, cool. So you can see here, it actually created this interface. It created this on a separate web page, and it should have done the same thing for you. It also created it right here within the Colab notebook. So I don't actually have to go anywhere. And I can start writing stuff in it. If I do something like this, hello world, and I submit it, you can kind of imagine what's going to happen. It basically takes this UI component, wraps it around my function, and so I can now start interacting with it in interesting ways. Okay, I can start using this for demos like I'm doing now. You can start using it for debugging too. Hey, interesting. Okay, I realize my function is maybe not case sensitive. This is a very simplistic example, but we'll see more realistic examples when we talk about machine learning examples. But this is just a couple of examples. There are a lot of different UI components that Gradio supports. There's a page here where we list them all out, but all of the common things that you can imagine, dragging and dropping an image, recording audio, sliders, all of that you can actually use to build an interface for your model or for your function. Any questions here before I get into maybe a more realistic example? If not, let me show an MNIST example now. So now that we have the core idea here, okay, so there's a question here. Could we use it for taking data from other people, like social media comments? Yeah, so if I understand your question right, you can, and I'll come back to that in just a second. That is definitely a very important use case, but I'll come back to that. So here's another example that I've created that I'm running here now. This here downloads a MNIST model and actually uses TensorFlow to load the model. Okay, and then it has this function called recognize digit. And what recognize digit does is it basically takes that input, it adds a batch dimension, it runs the model's prediction, and it returns a dictionary of predictions and their confidences. Okay. Now, the most logical input here is a sketchpad. So that's another input that we have. And another input that we have is something called a sketchpad. Now, the output here I'll mention is that rather than providing a string shortcut, so far I've always been using string shortcuts, but you can actually do something else too. You can actually instantiate a Gradio UI component. And this allows you to do things like customize the UI component. So in this case, I've customized it by telling it only show me the top 3 classes. Even if I have 10 classes that's being returned by the function, I only want to see the top 3 classes. Okay. And this will allow, when I run this, if I launch this, this will actually create this interface here. Okay, and then I can actually now run this interface. If I run this, I can literally draw different digits, and I can, I can see the MNIST model's prediction, and that's pretty, that's pretty neat. One thing you can do is you can again now start probing your model for what are its weaknesses. So one thing that I've realized is that the MNIST model is very sensitive to things being in the center. If you put things that are not in the center, you actually can break it quite easily. Okay, if it's in the center, then it's all good. But if it's not centered, it sometimes makes weird predictions. Okay, I'll talk about, so this is useful for finding failure points. But once you've found failure points, how do you actually do something with those? I'll talk about that in just a little bit. Any questions here? If people have questions, they can ask them. I'll also mention one other pretty neat thing that you can do. You can literally take the same thing I have over here, the recognize digit function, the input being sketchpad, the output, and you can just add the argument live equals true. If you do live equals true, what that does, let me run this again. If you do live equals true, you can actually start seeing predictions in real time. So it's going to take a second because I have to rerun this. I hadn't run that, but you'll see what that looks like in just a second. I'm just going to open this up here. Easy for it to load. Okay. One thing I will mention is right now I'm showing this in a Colab notebook, but of course this actually works anywhere. You can run this in a Python script, in your own Jupyter notebook that's running locally, or on a server. It doesn't matter. Or on a Kaggle notebook. This really works in any sort of environment. But here, for example, you can do things like start drawing, and you can see, for example, at what point did the predictions change from a 3 to this 8, and you can say, does that make sense? If there's issues, then you can flag those issues, as I'll mention in just a second. Okay, but you can get that just by doing live equals true. Okay. Any questions so far? Okay. All right. In that case, let me move on. I'm going to show a different example now with another UI component. This one's with the image input interface. And this here is the InceptionNet model. So what I'm doing is I'm going ahead and downloading InceptionNet. I'm going ahead and getting the human readable labels. And then I just have a simple function that basically takes an input image and passes it through through InceptionNet, returns a dictionary of predictions. And then now for my input interface, I have an image object, which reshapes my image to be 299 by 299 by 3. And then the label outputs the top 3 classes. And then if I go ahead and open this up, what this is going to do is it's going to show me that interface. And now what I have is I actually have an interface into my ImageNet model, and I can pass in things and see how the model will predict. Okay, cheetah. Okay, that's pretty cool. One other thing that you can do is you can start actually manipulating these objects, manipulating these input data. You can say, for example, let me understand, is ImageNet robust to rotations? Okay, so right now it's 91%. It's cheetah. Now it's still predicting cheetah, but it's a lot less confident. You can also do things like other sorts of perturbations that may be more relevant for your use case. Like you can say, okay, I want to know if it's sensitive, if it's robust to noise. Let me add quite a bit of noise. Okay. I can go to noise, and you can see that actually it's quite robust to noise. You know, it's 89% confident as to cheetah despite this. Forget the noise. Maybe you want to do something like change the brightness. Okay, if you want to use this model in the dark, for example, I don't know, nighttime. You know, is it going to work well at nighttime? I can barely tell it's a cheetah. And I guess for ImageNet, now it looks more like a leopard. Maybe leopards are night cats. I don't actually know. But you can start doing these types of things. The other pretty cool thing is that I haven't really mentioned this, but you've noticed that this whole time I have share equals true in all of these examples. And what that does is that actually creates a shareable link from my model. And so I can literally share this with you guys. Oh, thanks for who shared the notebook. Yeah. So I can literally share this URL with you, you guys, or I can share it with, let's say, my collaborators in the lab, or I can share it with on social media or something, and I can say, hey, I've built this model. I want you guys to test it out, and you guys can literally run this, and on your end, you don't need any sort of specialized hardware or software or any sort of dependencies, because all you guys need is a browser, right? All you need is a browser. You open it up, and the compute continues to run within this Jupyter notebook, all right? And the way it works is that basically on the remote users, they can run this on their laptop or on their phone, and the Gradio takes care of the message passing. It'll send the image to the host computer, which continues running the model. And then the host computer makes a prediction and returns it to the remote users. And so on your collaborators end, or on your testers end, for example, they don't need any sort of specialized anything, which really opens up the possibilities for who is able to actually test your model or use your model or give you feedback. You can send it to your advisor or your colleague or to your parents, or whoever you want, and they can start using this. Okay. And what they can do, and this is maybe the most useful feature, and this is what somebody asked about, is they can start flagging issues with the model as well. So here's an example of an out of distribution input image that I'm putting in. So this is a picture of Robert Downey Jr. is predicting suit. And maybe maybe suit is not a reasonable prediction here. So what I can do is actually I can click on the flag button. And what happens now is actually really powerful. What happens is that this feedback gets sent to the host computer that's running the model. And on that computer, a directory is created of all of the flagged input, okay? So you can see here this flagged directory and this name of my model. And you can see here, this input image is, so that there's a log file that's created that consists of the input data that was flagged, which in this case is this image, along with what the model predicted. So you can do this and say, okay, why is my model failing on this? Maybe I need more pictures of people. Or I can, take this image data point and then add it to my model, or add it to my data set to build a better model. So now, like, people are actually able to give you feedback on issues that your model is having, very early on, immediately. As you're like rapidly prototyping, you can send this link out, you can get feedback, build a better, more diverse representative data set, so you can have, better models at the end. And so if any of you guys actually try this out in the link that I sent you, and if you guys flag anything, this should actually show up. Let me refresh this to see if anybody did that. I don't think anybody did that yet, but if you were to do that, it would literally just add it here. So that's kind of cool. So any questions about this here? Let me check the chat.
I guess if I may ask a question, you showed us image input and also text input. So what other types of input, like audio, video, are you guys
Great.
exploring? Yeah.
All right, thanks for asking that. Let's go to the next example. So one thing is that we support different inputs and outputs. And so I think you asked about audio, and certainly we support that. And somebody else also asked about, can the output be images? Absolutely. So the question was, can the output be images when we use it for GANs? Yeah, in fact, let me just show, somebody tweeted something. A really cool application in a tutorial that they were building where it's a cycle GAN. And so it's the input is an image and the output is an image as well. And so they were using Gradio to actually demo that. So there's a lot of different input interfaces, and you can find a list of them on our website on the documentations page. So all of the input components are listed here on the right, on the left, and the output components are listed here. So things like audio, files, data frames, checkboxes, sliders can be inputs, and then the output component similarly. There's a variety of things, and you can also generate arbitrary HTML if you want to do different, fun things like that. Okay, business model. Okay, I'll get back to that towards the end. Cool. All right. Another example that I want to show is not only do we support a variety of different inputs, you can actually combine inputs together to create interfaces where there are, for example, multiple inputs into a function. And so take a look at this function here. I'm going to go ahead and close this. So this here, let me zoom in a little bit. This here is a function, number 4, greet, which takes in 3 input parameters, and it returns 2 output values. So if you want to make an input interface around here, you can, if you want to create, you can actually pass in a list of input interfaces corresponding to each of the parameters. So here, for example, I wanted a text box, I wanted a checkbox, and I wanted a slider, okay? And as the input. And then for the output, I wanted a text and a number. And so you can test that here. So let's say I'm doing something like this. I'm putting in Dania, let's say it's not morning in Riyadh. Let's say it's 30. And what this will do is this will say, good evening. It's 30 degrees today, and then the output is another number, which is just the conversion to Celsius. But yeah, so you can now use this to construct more complicated UIs if you want to, for example, have sliders that throttle certain properties. Someone mentioned GANs. If you want to have like input variables corresponding to different latent variables, you can have multiple sliders. Okay, so great question from the privacy perspective. That's really important. No, none of your data gets uploaded onto the server. We don't touch any of the data. This is just a message passing thing. So we just need some sort of public URL that we can use to actually send the data from your test user to the host user. And so that's what this is doing. None of your data is stored. In fact, if you want, you can actually run this locally and then set share equals to false, and then no public link is created whatsoever. So if you want to just test it locally or demonstrate locally, you can do that as well. So an example of that, well, maybe I won't show an example, but if you were to just maybe even download this Jupyter notebook and just run it locally, download this as an IPNPY file, and run it locally, you're going to see that instead of creating public links, these are actually going to create private links instead. The reason it's creating public links right now is because it's running in a Colab environment. Okay, cool. Does that answer your question? Yeah. Okay. Sweet. All right. We're getting something in the chat. Can it work? Okay. Yeah. So great question. Does it work with other libraries? So from a machine learning perspective, this is completely library agnostic. It doesn't matter if you're doing TensorFlow or PyTorch or scikit-learn. As long as you have a function, we can wrap a UI around it, right? So it's completely agnostic to that. I'm not specifically familiar with Folium. And the question was also about, can it support maps? So as of now, we don't have like a map UI specifically, but we do have very generic input interfaces. Like, for example, it can take in an input file, no matter what the file is, and it can output an HTML canvas, so you can put whatever you want on it. And if it's a map, that's great, whatever you want, really. And people have done very creative things. There's another question, but while, so someone raised their hand, I think. Okay. If someone raised their hand, feel free to ask a question. But you can really do very creative things with it. We have one user who we don't even know exactly who this person is, but they created this really interesting interface using Gradio where it's not the best example. Let's put in a different example. Let's say this cheetah example. You can put in an input image and it basically cuts it up into little, like 16 little pieces, and it tries to reassemble it using machine learning. It's very interesting. I don't know where they got this idea, but the point is here they were able to do whatever they want. They were able to put in a GIF here and to do all of this stuff because we can make we're pretty flexible in what we support on the output. Okay. All right. Did someone else have a question? All right. Maybe I'll show one more example in code, and that'll be the last of the coding examples. So maybe this is a lot of things, so I'm not going to go through all of the code. You can take a look at it. But the point I want to make is that there's actually a lot more what Gradio can do. So here's an example where I've added multiple models in parallel. So maybe you have two models and you actually want to compare their predictions. So this will show that. This will also show some examples of how to add metadata to your model, and I'll explain what I mean by that. Let me just go ahead and run this for now. Okay, so while this is running, let me explain what I mean by metadata. So sometimes when you create an input interface, you might want to add a title to the web page. You might want to add a description so that people know what they're doing, and you might even want to add some sample images, right? So because sometimes your users may not necessarily have an image off the top of their on top of their mind that they want to test, but maybe they have if you can give them sample images, they can get started by testing your model. So this is a very comprehensive example where we have a title, a description, some sample images, and let's see what that looks like. It's taking a little bit of time to load, but once it loads, it's pretty fast. Okay, so you can see that the interface is here. It has a title, it has a description, and you can now put in one input image, and you can see both of the predictions from both of the models, MobileNet versus InceptionNet. And you can see here the latencies as well, so maybe you care about that. You can compare predictions for something like this. And interesting, what you find is even for out of distribution images, it tends to make the same predictions, but or at least the top prediction tends to be the same. And they tend to make the same mistakes because I guess they were both trained on ImageNet. This is not a tricycle, but both of them say it's a tricycle. Yeah. So you can add examples, you can add titles, descriptions, you can have these two things in parallel. Okay. All right. So rather than me showing all of these different things, and explaining every single thing, I would like to show you guys something called Gradio Hub. This is something that we created that has a bunch of pre-trained models. I'll send the link right now in the group. Where is this? So I'll give you guys a second to open that up because this is a pretty cool thing where you can actually try out different. Oh, and if you think this is cool, you're welcome to give it a star. That way, helps us build legitimacy, and it helps. It'll also bookmark it for you if you want to come back to this later on in GitHub. But if you can actually open up any of these models and you can start using them immediately, again, from your browser. And you can put in an input image and you can actually run this immediately. And what this is doing is, again, it's using all we've done is we've taken the Gradio UIs and wrapped them around these pre-trained models and just making them much easier for anybody to use now. There's another question. Yeah, so there was a question here about, can we connect it to a database? What do you mean by that? Regarding privacy, you said host does. Yeah, so the host can be anybody. It can be literally your laptop. It can be a server that you have on premise. The host you can get this running on Heroku. We have a tutorial. And so the host really could be anybody. Any place where you can run Python, you can actually run this. Okay, when data is stored on a database. Okay, so great question. So I'll get back to that actually. That's something we don't currently support, but it's on the product roadmap. How can you use Gradio on NLP problems? Sure. So a lot of the examples that I've been showing are images, but you can absolutely use this for text as well and for other things. So we have some examples here. Let me show. So if you go into docs, you can see a lot of different examples that we have and a lot of different things. So for example, you see some text examples here. Here's an interesting one, text analysis. You can see here, you can put in any sort of sentence and then the output is passed through Spacey, I think. And you can see we're using it to demo a lot of really interesting things, like the different parts of speech, character counts, yada, yada, how many, what the diagram looks like. You can do that with all of that with Spacey. Okay. So again, any place where you have existing machine learning, we're not here to like change your machine learning workflow. You use your existing tools, whether it's whatever libraries you care about, whatever environment you work in, whether it's Jupyter notebooks or Python terminal, you're writing code in the editor. And what we're giving you is the ability to simply wrap a UI really simply around it so that you can then test it, share it much more easily. Okay. What about NLP for Arabic text? We actually have, I wish I had that link. We have someone she's actually using this to look at word embeddings in Arabic. But yeah, this is completely agnostic to language. And so you can literally put in Arabic text here. And as long as your Python function can handle the Arabic text, it's chill, it works. Cool. Yeah, thanks for all the questions. These are great questions. Let me go back. So yeah, try out the hub. That's probably the easiest way to actually just immediately start using different models and just seeing what you can do with Gradio. And you can do, like this is a fun one, I think, if this works. This one's like surviving the Titanic. You guys might have seen this from one of the most famous Kaggle competitions. But this is a live interface. So you can see, for example, if I set a certain fare, how does my age actually impact my ability to survive? How does my gender affect my ability to survive? Because as you guys know, on the Titanic, they would let I think it was young and female and the third and the first class passengers off first, and so you can kind of play around with that. Okay. So yeah. So there's a question. Yeah. Okay. Cool. I'll talk about the roadmap towards the end. Absolutely. But before I do that, I want to just show one case study where how we actually use this at Stanford. So, so my area of research, and I didn't get a chance to talk about this much at the beginning, but my area of research at Stanford was applications of machine learning to medicine. And so a very common workflow that we would have was that we would be working with a clinical collaborator, and they would basically collect all of the data and label it, and then they would give it to us. And we would pre-process the data, we would build the model, we would test the model, and then sometimes, when the model would be ready, we would deploy it and give it back to the collaborator to use. But it was very segmented. Like when I was building the model, there would be no input whatsoever from the clinical collaborator. And that would lead to a lot of the problems that I've been describing. And so what we wanted to change was this ability to actually work more closely with a clinical collaborator throughout the process of machine learning, specifically in the key steps of data acquisition and labeling, as well as model testing and QAing. If they could get my input on what data to collect, and I could get their input on how to test the model and QA it, we would have much better real world usage of the model. And so we ended up actually doing that for one of the papers that we wrote recently. This is a paper that came out this year in Nature Digital Medicine about deep learning applied to echocardiograms. And an echocardiogram is an ultrasound of the heart, for those of you guys who may not know. And what we did was we had this model that would basically take in an echocardiogram that I'm shown on the left and would predict different things about what's inside the patient's heart. And you can see here that this over here is a pacemaker. And we would be able to predict that there's a pacemaker inside of the heart. And we had pretty high accuracy. I've added the arrows here, but the arrows are usually not there. But we showed this to a cardiologist and they were like, does this really work? So we wrapped a Gradio UI around it and let them play around with it. And they actually edited the image, like I showed you earlier. You can also use the editor to block out certain things. And so they blocked out the pacemaker. And in real time, the prediction changed to no pacemaker, and the model went from 70% pacemaker to 90% no pacemaker. And when that happened, the cardiologist was a lot more trusting in the model, that the model actually worked. And to be fair, even the machine learning scientists, us in the room, when this happened, we breathed a sigh of relief too, because you can get a good accuracy, but you never really know a model is working until you can actually perturb it and see and make sure that it's actually working. And so this is an example of where these Gradio interfaces can help build trust and verify that these machine learning models are working in a robust manner. So I'll end here. I'll talk about the product roadmap too, actually. Actually, let me do that first. So there's a couple of things that are on the road. One is interpretation. This is something that we're hearing from people as well, is that we don't want to just know if this is if this is benign or cancerous, but we want to know what the machine learning model is looking at when it's made its prediction. So we have some really exciting work going on here. It's going to come out pretty soon, hopefully by next week, actually. Which is going to be an out-of-the-box interpretation framework. You can take any model you have, any image model or any text model, and we will figure out what is, what in the input is causing the model to make that prediction. That's pretty exciting, and we hope to, as I said, unroll that next week. Another thing that's down the road, probably next month or so, or by the end of this month, early next month, is being able to handle bulk input and show embeddings. So somebody asked a question about databases. So right now, one of the limitations of Gradio is it can only handle one input at a time. We're going to be working on extending the capabilities to handle lots of data at once and show the embeddings and show the predictions so that you can explore your entire data set at once, not just one little piece at a time. Yeah, so takeaways, Gradio is a library for interacting with trained machine learning models and sharing them. And our hope is that it can build more reliable models, more robust models. And to use it, just pip install it, visit the website where you can sign up for updates as we release these new features. And yeah, thank you so much for everyone here for listening and asking your questions and taking out the time on a Wednesday evening. Really appreciate that. Thank you so much.
Thank you, Abubakar. I guess we have some questions, if you can check them out.
Yeah, so somebody asked, NLP model and accept Excel. Yeah, absolutely. That is our hope. One of the use cases that we've seen is oftentimes you'll have a model and people are sending Excel files back and forth, full of, try this prediction. What is it? Is this correct prediction? That's not in our opinion, that's not really a nice way to deal with these models. It would be much nicer if the tester could simply just run the model themselves on whatever input data they want, tweak certain things. If there's issues, flag it without the machine, without having to do this back and forth. Let technology do the back and forth much more effectively. And so that is part of the plan.
So I like this part very much. It's like taking model testing to another level. So similar to what is happening with mobile development and others. So yeah, let's see if we have, I think we have another question here.
Let's see, question here is great. Oh yeah, okay. Oh, yeah, people asked about the business model revenue model. Gradio is completely free. It's open source. You can actually start using this right now without paying a dime or a real or anything. But what we, in terms of what the actual business model is, we're also simultaneously building an enterprise version of Gradio that's more focused towards the needs of large companies. If this sounds useful, like if you want to do a kind of large scale testing within your company, if you work at a company, let us know. We're happy to start working with you guys. We're in the early stages, so we're actually looking for design partners. And so if this sounds interesting for your business, let us know and we're happy to work with you. So no hidden costs. Yeah.
Thank you.
Abubakar, a question on the ultimate vision that you have for Gradio. Let's say in the near future. That's, you shared with us the roadmap, but was there like a feature that you had in mind, but you tried it, but it wasn't feasible at this time, and you wish to tackle it later?
That's an interesting question. Is there a feature that is not feasible at this time, but we're planning on building out later? Yeah, I mean, there's at the end of the day, you know, what we think could be extremely powerful is essentially something that streamlines how teams work on machine learning. So what we see, you know, again and again, we've talked to so many businesses who do interdisciplinary machine learning, and it's just like, you know, the chemists are speaking. So we're talking with a drug pharma company, and they're telling us, you know, that it's like the chemists are speaking one language, and the machine learning scientists are speaking another language. And the machine learning scientists ask for data from the chemists, and the chemists don't know what data to give. And there's just this lack of, you know, interoperability and ability to actually work effectively. And, you know, machine learning projects that should take, you know, days are taking weeks to months, and some of them fail because the right data isn't being sent over and all of that. So we would love if there's some way to like break, you know, to actually break this lack of ability to work together, you know, for lack of a better term. But this is, you know, this seems to be as much of a human problem and a communication problem as a technology problem. So we're still trying to figure out exactly what that looks like. We're doing our best, I think, right now to tackle it from a technology perspective, but I think there's a lot more to it. And just figuring out what are the best patterns of, you know, almost from like an organizational psychology perspective. How do we get very different teams to work together to build machine learning models? Because if you look at all of the exciting machine learning companies that are starting nowadays, they're always interdisciplinary. It's like, you know, machine learning applied to law, machine learning, you always have some sort of domain expert whose expertise the machine learning person doesn't have. And so like, how do we utilize this domain expertise effectively? I think it's such an interesting problem. And something that currently is not well understood or well solved. Yeah.
Yeah, and I think especially not only for researchers in terms of trying to debug the models or trying to develop or let's say reproduce the models that they have, but also in terms of startups trying to come up with an MVP for whatever feature that they have in their current products. This is extremely useful, especially like for current settings that we have. So we don't have to build everything from the start. That's fascinating.
Yeah, absolutely. Yeah, that sounds great. I don't know if you work at a startup, but you know, we are looking at as I mentioned earlier, some, you know, design partners. And so if there's like extra features that Gradio doesn't currently have, but you know, that would be helpful for your startup, ping me afterwards. You can reach me out on Twitter. Maybe that's the best way. And I would love to maybe work with you guys and you know and brainstorm what these features should look like.
Definitely.
Okay. The question about data pre-processing features. Okay, really good question. Actually, you know, that's another area to answer. It's related to the question I was just asked about what else would we like to include. As I mentioned, you know, the machine learning workflow, a big part of it is data pre-processing. And this is another piece right now where the machine learning person kind of does it by themselves. These features, oh no, this is an unrealistic feature to include. Maybe try this combination of features. Something that allows domain experts, subject matter experts, to give their feedback on how to pre-process data and select features, I think would be incredibly valuable. So that's another really good piece, actually. Thanks for bringing that up. Any other questions?
I guess that's all for today. Thank you so much, Abubakar. It's been a really insightful session, and we hope everyone enjoyed the session as much as we did. And we'll be posting the material and the recording on our social media accounts, so make sure to follow us on Twitter and Meetup. Additionally, we have posted a tweet, so if you can share what you guys did with your Gradio, with the Gradio app, if you manage to get something out, share it with us on Twitter, and we'll be sure to retweet it and put it out in the world.
Yeah, absolutely. I'll retweet it too.
Yeah, so that's our time. Thank you very much.
Thank you, Dania, for inviting me.
Thank you. Have
All
a
right.
good rest of the day. Thank you.
All right. Assalamu alaikum.